All right, so this next batch, we're supposed to graphically solve this and indicate whether each solution region is bounded or unbounded, and we're supposed to find the coordinates of each corner point. So that's kind of the key to this one. We're going to find the corner points. And so what we're going to do is we're going to first solve each of these for y, and then plot the points and get two lines, and then kind of go from there. So we'll have 3y less than or equal to a minus 6x plus 24 divide by 3 minus 2x plus 8. So that's going to be our first inequality that we can graph easily. The other one, we have 6y less than or equal to minus 3x plus 30. Divide by 6, we get y less than or equal to minus 1 half x plus 5. So now we've got our second inequality. And so now what we can do is we can plot both of those. So 0, 8, that's going to be about right here. And we're going to go down to right one, down to right one. So it's going to be, and it's going to be equal to, and so it's going to kind of come down like that. Again, as good as I can draw a line anyway. And then the other one starts at 5, so that's about there. And we're going to have a negative slope. So this one actually has a less slope, so it's going to come down something like that. And so now we've got kind of a box here thing in the middle. We had a triangle here, and an open area here. But we want less than the first one, so maybe we should draw this in different colors. So it's going to be everything this direction. And then our other one, let's make it green, is going to be less than the other one, so it's going to be down here. And our final thing is going to be, it has to be in this upper quadrant. And so that means this is our area that we're looking for here. Okay. All right. So now it says we're supposed to find each of the corner points. Well, 0, 0, that's the easy one. So now this one is representative of this graph. So here, if x is 0, y is 5. So that's going to be 0, 5. Now, this one is representative of this graph. So if y is 0, then we have to take 2x over here. And so x is going to be 4. So that's going to be a point of 4, 0. And then we have to figure out where do those two intersect out. And now this is where, calculators are going to come in handy, because sometimes we're going to have not just two lines, we'll have 3 or 4 or 5 lines. And so let's go ahead and figure out what that other point is using our calculator. All right. So first things first, we're going to turn off the uh, graphing one way or the other way. We're just going to have thin lines. That way we can kind of easily see it. And so let's do that first. And so let's that. All right. So now what we can do is we can figure out what our two equations are and clear those out. So our two equations were, we had a negative 2x plus 8, and we had the minus 1 half, so minus 1 divided by 2x, and then it was plus 5. Okay, and I think we should be still in the right region. Yeah, so we are. And so we could actually find all those points here, no problem using our thing. But the only one we really need to find, if we don't want to do any math ourselves, is to go over here and find 5, which is our intersection. And so we go and we find it. It's at 2, 4. Okay. Now, could we have found the others? Yeah. What we'd have to do is we have to do a value, and x is a 0. Oh, 0, 8. Well, guess what? That was not the one we need. We need the one that's red. So we need 0, 5 because we want that region here. And then the other thing we could do is we could do 0, a 0. And so what our 0 is going to be is that's going to be our left bound. Our right bound is going to be that. And that's the 4, 0. Okay. And then 0, 0, we get that automatically. So that's not a problem. So that's how we find all the different points. And so then the last one up here, that was the 2, 4. So let's write that one in. So we've got our points there, we've got our region, and so that's how we can solve these graphically. Okay. All right, so that took a while. So let's go stop there and we'll come back for some more.